Assalamualaikum and good day everyone. So my name is Nono Hashadwa binti Andri and my matrix number is S60367. So for Engineering Mathematics 2, I have been assigned to do a video presentation on Assignment 2 Question 2 under Chapter 5 Partial Differential Equation. So the question is, find a solution to the partial differential equation. And this is the given equations, which is del u over del t equals to k del squared u over del x squared, ux0 equals to fx, u negative lt equals to ult, and del u over del x negative lt equals to del u over del x lt. So this is the general equation that we know, and we substitute on the left hand side we substitute x with negative L, and on the right we substitute x with L. So we bring this equation to the left and we put the negative sign and equals to 0. And then we factorize gt, and we know from this we know that gt cannot be equals to 0, and we have this equation equals to 0, and we get v negative L equals to VL. And the second one is del u over del x negative LT equals to del u over del x LT. So we substitute x with negative L on the left and x with L on the right. So because of these two the same, so this is, we substitute into this equation, del over del t VL gt equals to k del squared over del x squared VL equals VL gt. And then we bring out the VL, and on this side we bring out the GT, and we put the same variables on the same side, which the left side is GT and the right side is VL. And then we introduce the separation constant, which is negative lambda, for this equation. So for equation 1, after we introduce the negative lambda, we get this, which is del over del t gt plus lambda k gt equals to 0 for the first equation. And for the second equation that we get after we introduce the negative lambda, is del square over del x square VL plus lambda VL equals to 0. And then this is the equation that we get, and this is the from equation 1, we use first order ODE separation method. So this is the first equation, and we bring this one to the right, and it will become negative. And then we integrate both sides, and on the left side we get ln gt, and on the right side we get we bring out the negative lambda k, and then we get this answer, and the ln we bring to the right, and we get g equals to exponent negative, g equals to exponent power of negative lambda kt plus c, and we can expand this one to this form, and then this exponent power of c, this is we can write this as a constant, so we get this answer, g equals to c exponent power of negative lambda kt. So for the second one, we have this equation. From the second equation, we get this answer, and equation 2 equals to v double prime is same with v double prime plus lambda v equals to 0, and we introduce with characteristic equation, which is r squared plus lambda equals to 0, and we get r equals to plus minus square root of negative lambda. And from now on, we let VL equals to Vx. So this is the two equations that we get after we solve. And then we need to find the value of lambda that suits with the Vx. So first one is lambda more than 0. This is the question of x Vx, which is C1 cos square root of lambda x plus C2 sine square root of lambda x. And first we let v0 equals to 0, and we substitute x with 0, and we get C1 equals to 0. And next one is V negative L equals to VL. So we substitute the x on the left-hand side equation with negative L, and we substitute x on the right-hand side of the equation with L. So we know that C1 equals to 0, and we solve this, we get 2C2 sine L square root of lambda equals to 0. And then for the del V over del X, this is the equation for lambda more than 0, which is negative square root of lambda C1 sine square root of lambda X plus square root of lambda C2 cos square root of lambda X. So we same like above, we substitute X on the left hand side of the equation with negative L, and we substitute X on the right hand side of the equation with L. And then we solve this equation, we get negative square root of lambda C1 sine L square root of lambda equals to 0, and we know that sine L square root of lambda equals to sine n pi. And we solve this one, we get lambda equals to n pi over L. Everything is square. Everything square. So next is for lambda equals to 0, we have Vx equals to C1 plus C2x. Same like before. On the left hand side, we substitute x with negative L, and the right hand side with L. And then we solve this, we get C2 equals to 0. And if C2 equals to 0, Vx equals to C1 and lambda equals to 0 is acceptable. So for lambda less than 0, we have this equation. For Vx is C1 cos square root of negative lambda x plus C2 sin square root of negative lambda x. We let V0 equals to 0, and we substitute x with 0, and we get C1 equals to 0. And next, we have the same one, and on the left hand side of the equation, of Vx equation, we substitute x with negative L, and the right hand side of the equation, we substitute x with L, and we, from before, we have C1 equals to 0, and we substitute it in this, and we solve them, and we get this answer. And since lambda is less than 0, we cannot let L square root of negative lambda equals to 0. And same goes to since L square root of negative lambda we cannot let equals to 0. So C2 equals to 0. And then we do the del V over del X, and this is the equations. Same as before, on the left-hand side of this equation, we substitute x with negative L on the left-hand side, and we substitute x on the right-hand side with L. And then we solve this equation, but we know that lambda cannot equals to 0, so C1 is equals to 0. So if C1 equals to 0, Vx for lambda less than 0 is no solution. Is no solution for Vx for lambda less than 0. So we only have two values of lambda, which is lambda more than 0 is Vx C1 sine n pi x over L, and lambda equals to 0, which is Vx equals to C1 cos n pi x over lambda. And the lambda value for both is n pi over L, everything square. And the GT is C exponent negative k. So we substitute the lambda value that we get with n pi over L square plus t. And then we substitute into the general equation that we get, which is from this equation, we put C1 as an, we put which is lambda equals to 0, we put C1 as an, so we get an cos n pi x over L times exponent power of negative kn pi over L square t. And for this, the second one, we get bn sine n pi over L times exponent negative k and pi over L squared t. And then this is the final equation for both, which is uxt summation from n equals to 0 to infinity an cos n pi x over L exponent negative k and pi over L squared t plus summation from n equals to 1 to infinity bn sine n pi x over L times exponent negative k and pi over L squared t. So this is the given from the question. So this one we get this answer. And then for the range of x from x equals or less from the range of x from negative L to L, we get a naught equals to this equation, an equals to this, and bn equals to this. I think that's all from me. Thank you.